Hello, my name is Amir Goldstein. I work for CTERA Networks. I never been to this one, Containers Plumbing Days, but I've been to several Linux plumbing conferences. And when you talk about plumbing, containers have a lot of plumbing, a lot of types of plumbing. So I do kernel development, so I'm in the municipal sewer type of plumbing. When you talk about kernel plumbings for containers, it's mostly one of the many things, C group, user namespaces, and ID mapping, if you guys know about that. And if you do, you probably know that many subsystems in the kernel are not user namespace aware or not ID map aware. And this is an ongoing effort to have more subsystems be user namespace aware so that containers could use the most of these subsystems. So in particular, I'm working mostly in two subsystems in the kernel. I'm a co-maintainer of overlay.fs, which is very connected to containers, but I'm not going to talk about this today. And I've been working a lot on the fanotify subsystem, or fsnotify subsystem. It's the infrastructure for that. Let me just say this quick, in case there's any confusion, and if I exchange terminology. fsnotify, filesystem notify, is the backbone, the kernel backbone, and fanotify is the user API. So inotify is another user API. They both use the same infrastructure, which is called in the kernel fsnotify. And I've been working for the past 9 years or so to improve the fsnotify and fanotify subsystems, along with the maintainer, Jan Kara. Let's see. So, why have I been doing this? I work for CTERA Networks, and they provide solutions for a globally distributed file system, where the end users, they access edge filers locally in their network. And those edge filers are typically have millions to billions of files on them, and when a user makes any change in the file system, that change needs to propagate around the world. So the first thing in order is to detect the change. So we're talking about scales of millions of files, many millions of directories, and thousands of users. And we need to make a detection of the change as soon as possible. How do you do that? If anybody has tried to write an application to do that, you will find that it's just not possible in Linux. It wasn't possible a few years back. Windows is much better than that, NTFS in particular. Apple also has specific functionality for that. Linux didn't have any. Linux only had inotify. If you've ever heard, I mean, if you want to watch a directory for changes, and systemd does that a lot, just a configuration directory, you put an inotify watch on that directory and you get notified. But that's it. I mean, you want to watch 10 directories, you can do that. You want to watch a tree of million directories, you would have to walk that tree and mark every single directory, and that just doesn't scale at all. There was no solution in Linux for that. There's a tool you can use, inotify watch, that recursive. You can try, but it's not very useful for this scale. So what I did back in 2016, I started to improve on fanotify. fanotify is just a newer API. If anybody has heard of that, you may have heard of it in the context of antivirus, anti-malware software. But I just took the API and extended it because it was more extendable API than inotify. and I extended it in order to provide the functionality of file system watch. So instead of watching a directory, watch the entire file system. Not a big deal. It was added gradually. First, the file system mark was added, and then many other features to support that. But the 5.10 kernels have mostly all the functionality in them already. And I also contributed to the iNotify tools project, the tool fsnotify watch -- file system, so you can use it in your distro. If you want the gritty details about all the changes to fnotify, there's a great talk from latest Linux Plumbers, linked here, about all the changes made to fnotify over the recent years. And so what does it give you, the fnotify file system watch? It just O1, you just put a watch and you're done. Doesn't matter the number of directories that you want to watch. If you want to exclude like specific noisy directories, yes, that's possible, and exclude filter exists. But there is no sub-tree filter, because that can be expensive, not in the kernel. You can do it in user space. And a big disclaimer, it's only for capsysadmin, right? So for us, we have an appliance, it's perfect, no problem. But for users, less useful, okay? So what can we do to make it a little bit more useful to users? So the first thing that comes to mind is maybe it's useful to have it in a rootless container, right? A few years back, the kernel gained the ability for rootless containers to mount a file system, specific file system, tempfs, overlayfs, fuse also. So we thought, okay, if a user can mount in its own domain a file system, why not let it be able to do everything else? So yeah, that was added like very recently, last month, I think, with the release of 6.16. I added this capability. I relaxed the restrictions, so fnotify can watch an entire file system inside a rootless container if that file system was mounted in the rootless container. But that's not the end of the story, because the permission to get notification on every change in the file system, this is something that I relaxed. But I didn't talk about the API. The API, when you're watching the entire file system, you do not get a path. Okay? What you do get, because path is like, it's not a stable thing. You get a file handle, a directory file handle, if anyone's ever heard about that. It's coming from the NFS world. It's like an inode number, but it's more unique, because when inode numbers get recycled, the file handle does not. So you get a unique identifier of the directory where the event happened, and you get the name of the file and what the event was. That is similar to iNotify. But when you get the directory identifier, a useful application needs to know the path. So there's a mechanism in the kernel to give it a file handle and get back the path. But this requires privileges. So again, within a rootless container, the admin of the container got the ability, I didn't put it here, but a little while back, got the ability to resolve a file, a directory identifier to a path, if that is in a file system that is inside the user namespace. So that's two components that needed to come together to provide that functionality. Now it's nice, a rootless container can watch its own file system, but tempfs, yeah, you're not going to have billions of files on tempfs, so I didn't get much from that. We really want to watch like big disk file systems, ext4, XFS, inside containers. So how do we get there? So what we said, the slogan earlier was if you can mount it, you can watch it, right? But inside rootless container, you can only mount these toy file systems. Unless, if you're familiar with mount FSD, so systemd provides the APIs for an unprivileged users to request a mount of an image. Like only root, the real root can mount ext4. But systemd provides a delegation. If user requests to mount this image file, systemd mount FSD has a whitelist of images, or if the image is signed, they say, okay, I can allow the user to mount this image because I trust this image. And there's a set of rules that allows plain users to mount ext4 XFS. And so it's a matter of policy. It's a matter of managing things. So should we allow rootless users to be able to watch all the changes within this specific file system? Well, the kernel cannot give the answers to that, but something like systemd can manage this. So how can we leverage that? So in a very simple way, the same as a non-root user can request a mount of ext4, the same non-root user can request from a service to watch, to get all the notifications from this file system. It's pretty easy to do. I have a demo. I have no time to do it now, but I can do it in the demo session. Just splits the fanotify to a service and a client. The service is much like FS events D in Mac OS. It's a root service that gets all the events from the file system. And then it decides, well, my demo doesn't decide, it just grants you the permission. But the idea is that an authorized service like systemd service can decide who is entitled to get a stream of events. And then what remains is that the user getting the events needs to be able to decode those file handles into path. And that's also been done recently, but I can only show this in the demo. But just the slogan is if you can request to mount it, you can request to watch it. And that gives us something that's useful, because then like my employer, CTERA, can take their application, their filer with millions of files, and run it inside a container of a workload, which is rootless. Yeah, that's it for me.